the officials tell us that all of these outbreaks are imported outbreaks, that there is no more endemic measles, meaning native to the land. What was here, all the virus that was native to this land is eradicated. So therefore, we have to keep vaccinating because measles is still in some other countries and people travel and bring measles back. Therefore, we have to keep vaccinating. So we would think, okay, so if everyone or most of the children are vaccinated here, then what are these outbreaks, right? Are they occurring only in those who were left unvaccinated for some reason? Or what is going on? But actually, no. If you look at the papers, the medical literature, you will see that measles outbreaks involve not only unvaccinated, but also vaccinated children. And so I will just read the titles. Measles outbreak in a vaccinated school population. Major measles epidemic in the region of Quebec despite a 99% vaccine coverage. Outbreak of measles in a highly vaccinated secondary school population. And the last one, pretty recent, the largest measles epidemic in North America in a decade. So all of this is published in the journals of public health or epidemiology. So let's look a little bit more specifically into the last paper, the SARS 2011, because this is close to our times and to home. So this is the outbreak that happened in Quebec in 2011 in the spring. And here's a few curious details that I took from this paper. So this outbreak, it's post-elimination era, so it's an imported outbreak. It was imported by a high school teacher, an adult. He was himself vaccinated against measles in his childhood. So he went on a spring break abroad, and then when he returned, he got sick, he felt sick, but for the first 3 days of his sickness, he was still teaching. And because of that, I guess not realizing that how could that be measles or anything. Measles in the beginning looks like flu, really. I had it, so I know. So probably he didn't realize. So he was teaching, and he infected a lot of high school students, right? And the students then infected the whole community around. So from this one teacher, the mode of transmission, and about more than 600 people in the community got measles. The thing about that community is that it had really high vaccination coverage. So 95% of high school and 97% of the community were vaccine compliant for measles. And there were no pockets, concentrated pockets of unvaccinated groups. We have that sometimes in the United States where there are Amish groups or some religious groups that they live together, they don't want to vaccinate, but that region didn't have that. So that's why with vaccination, they keep raising this threshold. They were telling us, okay, maybe it's 70% that we need, then 80, then 90, now we need 100% to ensure herd immunity with vaccination, right? And even with 100%, a few years down the road, those who are low responders will no longer be a part of herd immunity, right? Will no longer contribute to herd immunity. And it's not their fault, and we will see why. The thing is about this, there was a study also that those who were low responders, and they responded very little after the first boost, after the first vaccine, the second vaccine is not going to boost their titers much more. It would be just like here, just a little bit up and back to the background. And why is that? We actually have an explanation. An explanation comes from no one else but Dr. Gregory Poland. Him and the establishment, I guess, are aware that children respond differently to measles vaccine, and some are high responders, some are low responders. And so they hypothesized and confirmed their hypothesis that this correlates with genetic variability. And I guess I'm a low responder because I got measles after only 5 years after my last vaccine. And if they're low responders, they're not going to really get much benefit out of that vaccine, because a few years later, they are back to being susceptible again to measles. And it's only these high responders that we would consider benefiting if the benefit is to prevent measles, right? But really, the whole reason why we started eradicating measles is because it wasn't really deadly in older children, right? It was deadly in infants. And infants cannot be vaccinated. So therefore, we thought that we would be relying on herd immunity. And yet, we cannot rely on herd immunity. And when the real outbreak happens, infants still get involved in it. And there is no way around it now. Well, if there is a genetic variation in how humans respond to vaccines, there might be also genetic variation to how vaccines generate adverse reactions, right? Because we vaccinate almost everyone, and some kids come down with adverse vaccine reactions and some don't. So it is reasonable to assume that there is a genetic susceptibility to that. There could be other factors too, metabolic susceptibilities and others, but genetic is something that needs to be addressed. The thing is that Dr. Poland acknowledges that there could be a genetic susceptibilities, right? From this, acknowledgement to actually having all comprehensive set of data that we can catalog which gene and which vaccine would result in combination would result to adverse effect, and to be able to predict in advance which kid is likely to have the adverse effect and which kid is okay, we are really far from that. So right now, whatever decisions that we are making in terms of when we try to estimate the risk of vaccines, we cannot really make personalized risk-benefit analysis, right? Because we just don't know that information. We know it's happening, but we don't know what we have to correlate with what. So this is the situation that we are in. Okay, but then we have also to think whether the reduction of exposure to the virus is a good thing. And I would say that it's not necessarily a good thing, because although we are eliminating the virus, we are also at the same time eliminating something else which is very precious, and that's maternal immunity. And we are eliminating maternal immunity much faster than we are eliminating the virus. So let's take a look at that. And so the majority of kids had their measles or their mumps or rubella by the time they are 15, right? So by the time they are childbearing age, they already have immunity in the past. So here there is data that actually estimates the proportion of measles immune by age, right? And it correlates pretty much as the majority of kids have their measles, the levels of proportion of immunes in the population grows and almost reaches 100, maybe not 100, but close. And mothers, sort of the mothers of all mammals, including humans, they have the ability to transfer their immunity to infants. And they do it through two methods, or two sort of ways. One is through placenta during pregnancy. Some of the serum goes through, and that sort of protects the infant, if, of course, the mother is immune and has those antibodies. And after birth, this protection lasts for about 6 months. It just, those antibodies that still linger in the baby, but then they sort of go away, right, because the mom and the baby are separated now. But then through breastfeeding, this kind of protection can continue, because then when someone gets measles or any infection, the mucous cell immunity forms these cells, which during pregnancy migrate to the mammary gland and secrete antibodies into the breast milk, right, once it started to be produced. So then you can extend this protection for as long as you breastfeed. And so in the 60s, in the United States, moms were not really breastfeeding. There was like 10 or even less % of women who were breastfeeding. Right now it's a little bit, the trend is reversed and it's growing, the awareness of it. So all those babies, starting from 6 months, so there was no measles before 6 months, so very rare, because there was still maternal immunity that was transferred through placenta and that lasted until 6 months. But from 6 months to, let's say, 2 years old, right, it's still this somewhat vulnerable period for infants. Breastfeeding could have taken care of it if women were encouraged to breastfeed. So then we would reduce, measles mortality in the young kids. So let's see what's happening here instead. This paper describes an outbreak in the United States that happened in the 90s. So that is the last outbreak that was there. And it looks at the infants who were exposed to the measles virus. There was a known exposure, so these infants were in contact with someone who within a few days developed measles. Some of the infants developed measles and some didn't, right? So the researchers wanted to see what makes the difference. And what made the difference was the year of birth of the mom. And so moms who were born before 63, when the measles vaccine was introduced, were less likely to have their infants have measles compared to younger moms. And this trend was kind of proportional to when they were born. So this is something that is very sad, that we are eliminating something very precious. We will be eradicating maternal immunity with those viruses too, so we will be repeating the same mistakes that we didn't learn from this. Natural infections lead to permanent immunity, and we talk specifically about viral infections, right? But then attenuated or inactivated viruses, they don't. They have transient protection, and that also depends on the genetics, right? And so the reason why it is so, or it correlates with that natural infections or infections with natural, even if you just inject a natural virus, right? That would generate protective serum titers that stay high and kind of level, at least in mice. But the protective serotypes wane quickly after exposure to attenuated viruses. And there is also considerable genetic variation in the human population and in how it affects the immune response, and it cannot be corrected by boosters. So whoever is low will be low. And the last point is that with mass vaccination, what we are creating is a leaky herd immunity, right? So the infection could just leak through because really only a small fraction of the population are high responders. And because of that, this leaky herd immunity fails to protect those whom it's supposed to protect according to the officials, the infants. But mass vaccination on the other side undermines maternal immunity, which would have provided robust protection if we used it to the full capacity, right? If we didn't just stop with at 6 months with just placental protection, transplacental protection, we would extend it by breastfeeding. There is some controversy with polio, that polio virus is eradicated, but the disease that looks exactly like polio, which is called acute flaccid paralysis, is soaring in India. And it's caused by who knows what. But it's not caused by polio because they cannot even identify polio in there. But again, the vaccine immunity is not the same as natural immunity, naturally acquired immunity. So it's possible to get the vaccine and then still you have to worry what to do about disease because you can still get the disease. So there are molecules or substances or proteins in breast milk that have either very specific or very general antibacterial functions. There are also very important the gut flora of the baby because lactobacteria that a breastfed infant has and formula-fed infant doesn't it is actually promoted by breastfeeding, and there is a specific protein called lactoferrin that promotes the growth of that bacteria and inhibit the growth of some bad bacteria, you know, the ones that are not favorable. There are also empirical data where they show that breastfeeding is protective against invasive bacteria, against ear infections, against meningitis, things like that, and against diarrhea, so any intestinal problems. There are also data on long-term benefits of breastfeeding in the reduction of chronic diseases. So there is everything to be gained from breastfeeding, and nothing to lose. And if an infant needs one vaccine that is 100% safe and effective, that would be breast milk. In countries like Africa, where vitamin A deficiency is widespread in kids, measles is a deadly disease. Kids with measles over there, they have to be treated with vitamin A, and that really helps with mortality, reducing mortality. However, you don't need to wait until you get measles to start with vitamin A. It's much better if you have it ahead of time, because really the symptoms of the disease start 2 or 3 weeks after you got the virus, right? There is an incubation time, and you need your interferon and vitamin A pretty much right away. So we have to be, have vitamin A at all the time. So vitamin D, there is also some literature on that, specifically with regards to flu. And what vitamin D does in the immune system is that it activates some of the cells of the immune system against the innate defenses. It makes them secrete substances which are known as antimicrobial peptides. And those substances, they interfere with the replication of enveloped viruses. And flu virus is an enveloped virus. And this can explain why we have flu mainly in the winter or fall months, and nothing much in the summer, because in the summer we have enough vitamin D through the skin, right? But in the winter we have to supplement. And the thing is that northern societies who are healthy, like Vikings or Eskimo, they had plenty of vitamin D in their diet in the form of cod liver oil or fermented fish or whatever else. And that we know from the research of Weston Price. People probably familiar with that. So Weston Price diet is actually, you might know, it comes up to be very high with vitamin A and D. And they tell to maintain that diet for a different reason, right? For tooth decay, for general health. But actually, there is enough in the literature on immunology that exact same vitamins play a role directly in the immune system. And so you don't need to go after one disease, then another one. You just do one thing, and it kind of covers pretty much everything. So then another important thing to know is the effects of anti-fever medication, which is also called antipyretic in the medical literature. Very curious study was done in Japan by Sugimura. So what that study revealed is that children were admitted to the hospital due to high fever, right? So that was a study of children with high fever in the hospital. And some of them proceeded to develop pneumonia, and others did not develop pneumonia. So then they wanted to know what was done, or how were these children handled, those who developed pneumonia versus not. And one thing that came out was the children were treated, when children were treated with Tylenol, paracetamol, I think, in this country, they were more likely to develop pneumonia than if they were not treated or lower levels. And so this is not a placebo-controlled study or anything. It's more like a correlation, but they're actually researching animals, which is more in line with placebo-controlled, where they infect animals with some bacteria or virus, and then either treat with fever-suppressing medication or not. And the animal group that is treated has much higher mortality rate from that bacteria than those who are left untreated. And also, we know from studies like here on measles and chickenpox that you just get the disease worse in terms of complications when you treat children with anti-fever medications. So those are a few things that, you know, they're so obvious, and there is enough in the literature to kind of alert us. And of course, once we get that in place and we want to further fine-tune your health and your resistance, and we cannot separate the immune system from the rest of the body, right? So whatever affects the rest of the body, such as toxicity or oxidative stress, it will affect the immune system too, the function. The whole point of doing this vaccination is to protect infants, and it doesn't work.